What?
No, you can click on full screen.
No, it doesn't.
It's working well, I know.
Yeah. All right, so in this...
Now I need to get my pointer back to this screen. I don't know what.
You're here.
Other side.
Ah, there we go. Yeah. Sure. That was not easy.
Okay, welcome to the second session, which is the ex-Google and Google session, basically. So we have Marcel kicking us off, who's one of the co-organizers, but he's going to talk to us about the configuration continuum. Take it away.
That's extra embarrassing being one of the organizers and not have my digital setup. Anyway, I should have used the break more, more better. Yeah, so 2 years ago I talked about Q as well. It was virtual then. So there I talked about the mistakes I made at Google with the designing of GCL. And again, my sincere apologies for everybody that has to put up with that crap. But you know, like it's still used a lot at Google. It's a large language, so I guess it has its uses. So I talked about so what mistakes I made, how we address it in Q. It was a lot about sort of the model of cumulativity. So this time around, I'm going to talk about a little bit on what is configuration, right? Instead of focusing on Q too much, there will be Q examples in here. But it basically explains more about the principles of Q and like what it does and what it tries to solve and why is it important and that kind of stuff. So so here's a tweet from Kelsey Hightower. So what's interesting about this is, we talk a lot about declarative configuration, and our mind is very often then like, oh, it's some YAML file or whatever, right? But here you can see the way he talks about it, that it's a much more operational and dynamic thing, and configuration actually encompasses much more than just a few data values, key value pairs or whatever. So let's try to see if we can find configuration in a real life system here. Some of the people that were at Dax will already know this example. So we have here a very simple Pong server where people can send a ping request and get a Pong back. Of course, it's very important that we audit all of this, right? So there's a database with an audit trail. Then there is an open policy agent with some authentication, right? Because we don't want everybody to send ping requests, right? Like it wouldn't be good. And then we have some Terraform, like setup that can actually deploy these servers to a Google Cloud platform, right? So where do you think the configuration is? Well, very obviously the Terraform configuration is a configuration, right? Like I think there's no dispute about that. Also, if you look at the Pong server itself, right, this is a binary that might have some configuration, some values that people might set, right? I think there's not much of a dispute there either. But where else? So let's look at the database. Of course, the database has to be set up and configured. But what about the database schema itself? Is that configuration? Well, let's assume it is for now. We can see later why this might be or why you might want to consider this as configuration. But here on the left-hand side, we see a table schema definition for this database. And on the right-hand side, we see the equivalent in Q, more or less. So you see that Q allows you to capture this schema like pretty much verbatim at what it is. There are some Q-specific things here, you don't have to worry about it, but basically this is the schema, right? So we have a method. That should be string 100 here, like in reality is get post, but should be string 100. Comes back later. And then there's a timestamp, which is of type, right? And that's really it, just a schema. So where else is there configuration, right? So we already talked about the configuration of the server itself, but let's look in the server code. Is there maybe configuration there? So of course you can have flags. That's our obvious configuration elements that you can find in code. But we also have this Go type called audit, which is remarkably similar to the database schema you saw earlier. And if we want to encode that, so on the right-hand side, again, we have Q. And this is basically the schema in Q, how it will end up being. And you can already see there is a discrepancy between the Go schema and the database table schema because the strings are of different length, for example, right? So you see here that even though it's like a data type, there is a possibility for error here if you don't consider what the database schema is really like. But we're not done, right? So we also have this policy definition for OPA. It's something very, very simple, right? We just say if you have an input method, it should be get. So for the Go server, I can tell you, right, it would support both post and get. But in the policy, we say like, no, in this case, we only want maybe certain users, but in this case, all users, we only want them to be able to use the get method. So very simple. On the right-hand side, there's one way to do it in Q. There's many ways to do it in Q, but this mimics what Open Policy Agent does to the most extent. So you could say that this is actually also configuration because it puts constraints also on how the system can be used. Can be validation, can be policy. So now the writers of this, developers of this system were very nice to also publish an open API definition of their service. And if we take a look at this, you could argue this is also configuration, right? This is more at the other end of it. So we have the open API definition. And then on the right-hand side, we see the Q equivalent, basically. So one thing that's interesting here is, so in the Open API, we only have the get defined here. So you see the equivalent in Q. And essentially what you can now do in Q, right, like we could also say, okay, let's put the policy for this Open API in Q rather than in, so I'll go, oops. So you can put the policy definition in Q rather than in Open API, OPA, right, like Open Policy Agent. So this is another way of putting that restriction in, right? So here you can see that sort of the domain is a bit blurry between the schemas and the APIs and the policies, right? It's all sort of like this continuum, if you will, of configuration. So. Yeah, so basically the conclusion of this here is that configuration is really everywhere, right? You have it at all kinds of different levels of abstractions. It all interacts with each other. And it's actually, you know, there are some possibilities of errors here if you don't keep this stuff in sync. So why is this important? I don't have to put much, spend much time on it because a lot of the speakers already mentioned that today. We have lots of outages. So basically over 50% of the outages are configuration related typically. So one thing that's interesting to add here, what I've seen, there's a lot of research I've looked at. I've also spent some time at Google and the SRE research team looking at configuration or outages in general, but also configuration related outages. But also if you look at other research, this 50% number, 50 to 60% seems to be pretty constant. But the type of configuration outages that you see are very different. So most of them, for most of the research, it's just simple values that a server doesn't support that people specify. So at some companies, let's say at least, this is not the case, right? Like they don't have these errors almost at all, right? Like the configuration errors tend to be much more complicated. So my observation is a little bit is like you can, as the company matures more and sort of gets rid of these simple configuration errors, also the systems tend to become more complicated, so also the configuration errors tend to become more complicated. But this 50% number seems to be pretty stable. Yeah, so in general, this is also addressed in other talks today, right? Like the testing of configuration is quite important, right? And it's often sort of neglected compared to testing for software. So what can we do about this, these outages? Well, again, validating, testing, typing. So policy enforcement is a tricky one, right? Because policy enforcement often has a dynamic element to it. So this is often used as an argument, we cannot do anything about this pre-deployment, right? But really what you want to do is you want to, this is also was a point in my last talk, but you want to fail as early as possible, and the popular term for that nowadays, I'm sure this will fly over again, but it's shifting left, right? So you want to fail as early as possible. And the argument for policy is because it's dynamic, you can't, but we really think you can. Actually, you can do that. You just need to think a bit differently about it and structure it a bit differently. So one thing that makes this more complicated is that configuration is a cross-cutting concern, right? So what you see is that with most engineering, you have like these components and you build this in this pyramid fashion. You build smaller components, you build larger components from these smaller components. So in configuration, it doesn't really work like that, right? Like you have different departments that all have their opinion on what this configuration should be. It comes in from all these different angles, and there's no real natural order or layering to this configuration. So if you try to impose this natural ordering, you get this combinatorial explosion for no particular reason, and it just makes things harder, right? So, and then the other thing is these different levels of abstractions, right? So if you really treat policy and schema and data all as something different, you can make your life quite a bit harder. So what do I mean with levels of abstraction? So here I see a hierarchy which we call the Q continuum, you know, with types, API, policy, validation, templates, data. These are all different aspects and different angles of configuration. I'm sure there's much more. You can come up with tons more names, but this is sort of a ordering, arguably in order of you know, increasing specificity going down. That is not the reality, though. The reality is more like this, right? So it's often very unclear what exactly is policy. I mean, maybe if you write things in Rego, it's very clear this is policy, right? But very often, if you then look, and I've seen similar things in GCL, for example, if you look at assertions versus the templating, very often that contains the same data. So there's a lot of overlap between templating and policy or validation, for example. To give you one concrete example of this, so here we have like, let's say, a little configuration that, or template, you could say, right? Let's say A must be an integer, B is A plus 10, right? So what is this? Is this validation or is this a templating, right? You could say it's a template because if people specify A, you automatically compute B. But you can also say it's validation, right? Like if A is specified, then B must be A plus 10. Right, so it can be both. If people specify both A and B, then all of a sudden it turns into validation. So here you can see it really goes in both directions. And this is from so Q is not something unique and new. This is like a 30-year-old technology where it was used in natural language processing. And the key element which they mentioned, what is the nice property of this graph unification, is that constraints are templates, right? And you can really use them in any direction you want. That's a nice property. So one element of this cross-cutting aspect of configuration is that you really want order independence, right? Like you really don't want to get this combinatorial explosion if you by having to apply order to all these different aspects. So having something that's commutative is quite important. And this is where you see that traditional software engineering really departs a bit from what we call configuration engineering, if you will. Because like inheritance and overrides is something that's quite common in software, but we think it's really a bad idea to do this in configuration. Hey, get down. Oops. So what is Q? So Q basically addresses this by introducing this lattice-based model of configuration, right? So we have types R values. Basically, it doesn't really distinguish it. It's very fluid between the two. All configuration is defined in a partial order, which is a lattice. It's constraint-based. It's a constraint-based language, essentially. It's also aspect-oriented. I'll come back to that later. It's very composable, right? Like this was when we did GCL and for some bad reason decided not to use unification in the beginning. It's like, well, but it still needs to be composable. I really don't know how to make things composable without using unification, quite frankly. But yeah, because we use unification, it is a composable, and by some definition of composable. So of course, so like where it is commutative and associative and idempotent. Q is also a propagator network. If anybody's interested in computation models, but that's sort of the wrong conference here. So here's a nice. This makes it a little bit more concrete about the Q continuum. So at the top we have a type, at the bottom we have a piece of data, in the middle you have something that is somewhat in between, right? So this is like a short visualization of Q. So this is at the structural level. Here you see it for specific values, right? Like you can have string, number, but you can also have regular expressions and all this kind of stuff. And this is all ordered in this lattice. So numbers are arbitrary precision decimals. That's another big problem we did with GCL. Like, don't use 64-bit integers because you will actually run out in describing things. And also it's a floating point. Let's not even talk about that, right? Already mentioned that. So how does this all look like in Q? So how would you actually express the different aspects in Q, right? How do you model this? How do you even think about bringing all these different pieces together? So one idea in Q is that you say, like, well, every aspect of configuration, whether it's a tiny little element or like, you know, some schema, it all has like this place in this namespace, right? Everything has an address, if you will. And then once everything has a place in the configuration space, you can just use you know, your standard aspect-oriented programming techniques to assign things in place based on patterns and stuff like that. So here you have an example of a very simple service. We have a ping and pong and any combination of environments, production and development. And we have a deployment and a service. This is modeled after Kubernetes, but it could be anything. It's just some permutation of a bunch of variables, and you have all these different configurations, right? So let's say we now want to set the Pong deployment in production, right? So the address that you see is up there, right? Like it's msprot deployments Pong, and then we have some arbitrary set of values that we want to set at that location. But what if we now want to set both production and development, right? So here we see this is like a Q annotation for wildcard in the second position. So this say for any production and environment, or for any environment, so production and development, we want to set something for the Pong deployment, right? So basically you have this pattern matching for selecting you know, elements within this tree, you know, often more than one. So here you have two wildcards, right? Let's say we want to say something about deployments in general, no matter what it is. Like maybe we want to say, you know, you have to monitor or whatever, enforce certain monitoring policies. Then the SRE team that is responsible for monitoring says, like, anybody here that launches some deployments, we want them to set some monitoring. And you could specify it like that, right? It's just a matter of setting the wildcard. So basically another way I sometimes say I can think about it is if you have JSON, which is a tree of values, if you will, you can think of it as a sequence of path value pairs. And then you can generalize the values into types, and then you can also generalize the paths into pattern matching within the tree, basically. So back to our example, right? So we've now shown how Q can basically, how you can compose all these different aspects together in this single space. But the example had no Q, right? It was all like Go and database tables and all these kind of things. So like, okay, great, right? Like, do we have to move everything to Q? So, right, the idea is that Q can serve as this sort of interlingua, sort of this intermediate representation for all the configuration space. This, of course, is a lot of work, right? We have a bunch of these adapters. It's sort of depicted here, what we plan to do, what we have done. So Q is basically data log equivalent. So it should be quite straightforward to look at the holes in the configuration, convert it to SQL, all these kind of things. So it makes integration quite feasible. Rego is essentially data log. So one nice thing you see, if you picture this continuum where you have all these different types of configuration, you see that policy was sort of at the center of it. So policy is really the aspect of configuration where they most sort of grapple with, needs to come in from different cases, and there's overlap. So you see that in the policy language world, almost all of them are logical programming languages, right? Because there you can really see you benefit from that the most. But we argue it should actually be logical programming across the spectrum. So how can you then do this with Q? You can basically put Q in the middle, right? Like you can basically suck out or extract all these information you have in all these different things. You have adapters for Go, you have adapters for all these other things, right? Terraform is essentially JSON. You can suck it in and then basically put it in this single bin, right, based on the namespace and see, does this validate, right? Are there any inconsistencies? So we use the order independence here to just dump it all in. So a little bit about the Q community. So Q, we talked about configuration now, but it's really used for many other things. That's probably the largest use case is composable workflows, which if you squint very hard, or especially with the definition for configuration I gave here, is just configuration. So ML pipelines, API generation, that's where Istio uses it for. So they get all these different aspect validations from different parts and then combine it together and output. It's a little bit less elaborate than what I make it seem now, but then output APIs. Somebody also encoded the US text code in Q. And the reason there was is also the logic programming aspect of it, that you can, you never know how you want to use it. So sometimes you want to input this, sometimes you want to input that, and then you can just pivot around it, and you have, you can create a library for however you want it. I don't know if they also implemented AMT. That would be tedious, but for the Americans here. So these are some of the users. It's actually an old slide. There are a bunch more now. This is the team. So like Daniel, Roger, and Paul, they have been working on modules, like having creating a nice module to allow for a nice module ecosystem. Aram and I are here at the conference, so if you have any questions related to Q, please come ask. And then there's Dominic. He's off right now, so not able to answer questions. I don't know if any time left. I think I spent 5 minutes on the 10 minutes on the slide setting up. But.
Let's thank Marcel.